Hello, I'd like to show you how we can use the calculator in an easier fashion. There are two functions on the Inspire calculator to help us handle binomial distributions. One is called the binomial PDF, and we use that when we have exact case. So the parameters are n, the fixed number of trials, p, the probability of success, and x and k are really the same thing, which you want to see. And the other is the cumulative density function, and that you use when you have the at most and at least case. And the formula for it is binomial CDF. N is the fixed number of trials, P is the probability of success, low is the lowest value, and high is the highest value. So let's apply this to an example. Ladies' Home Journal magazine reported in 1993 that 66% of all dog owners greet their dog before greeting their spouse or children. Suppose that 12 dog owners are chosen at random. So this is a classic case of a binomial distribution. We have been satisfied. Either the dog owner is going to greet them or they're not. Each dog owner is independent. We have a fixed number of trials. We have 12. And we are giving the same chance for each. And so we're going to write this out like we normally would. So k in this case is 7. So let's fill in our parameters. So n is 12, k is 7, p is 0.66, and q is 1 minus p, or 0.34. And we would substitute in the formula just like we did before. And then I'm going to show you, we're going to enter this in the calculator as opposed to using the function. And I would still want you to write out this work plus the calculator command. So in this case, it's binomial PDF. N is, in this case, 12. I should write the command out just so you could see what it is. It's N, P, and I'm going to write out K. So it's going to be N, P is 0.66, and K is 7. So let's go to the calculator, open up a calculator page. And when you do that, you're going to hit Menu, Statistics, Distributions, option number 5. And you can see that option number A is, so we're going to choose option number A, and we're going to choose N for, not 122, this is very sensitive, 0.66 for the probability of success, and 7 for K. And you get 0.1963. Let's continue on for part B. Find the probability at least 5 of the 12 dog owners greet their dog when they arrive home. So in this case, this is an at least case, so it's a multiple case. So you're going to have k is greater than or equal to 5. Just make sure you always read carefully. So in this case, when you write it, this is how the work I would expect you to show. So it's going to be n is 12, k is going to be 5, comma, 12, p is 0.66, and q is 0.34. We start substituting in. Twelve minus 5 is 7. And then what I do is I normally go plus ... and I write out the last term in the expression, which is 12C12. For the command line, let me just do it in a different color. It's going to be binomial CDF, cumulative density function, and it's going to be N, fixed number of trials, P, the chance of success, the lowest value, and the highest value. So let's write that out. This is both the substitution into the formula and the command line is what I would expect on a test. And let's go to the handy dandy calculator. And you're going to go in the calculator page, menu, statistics, distributions, and be careful that you choose the right one. You want the binomial CDF, that's choice B. We just fill it in like we did before. In this case, it's 5. And then it's going to go to 12. And we hit OK. And you get 0.9787. Would like to do part C and D of this problem. What is the expected number of dog owners who greet their dog first when they arrive home? So when they're looking for the expected number, what they're really looking for is the mean of the distribution. And the mean of the distribution, you can find the formula right on the AP exam. And that's just N times P. So in this case, it's going to be 12 times 0.66, which turns out to be 7.92. And don't round up, just leave it as 7.92. And what that means is, on average, we would expect 7.92 dog owners to greet their dog first when they arrive home. This formula for the standard deviation of a binomial random variable is square root of NP times 1 minus P, or NP times Q. So it would be the square root of 12 times 0.66 times 0.34, which is equal to 1.641. In any case, now it's time for you to practice. Let me know how it goes.